Hello there. This is our third set of notes, so if you've gotten this far, nice job sticking with it. This method is called the elimination method, and we're going to work with this to eliminate something. And really, both of the other types of methods we've used also do some elimination, because the idea here is we're always trying to get rid of one of the variables, because we can only solve an equation with one variable at a time. So the elimination method is going to be that method where we solve the equations by making sure that we have one of the variable pairs as opposites. So we're going to set one variable pair as opposites. And then this is the weird part. We're going to add together our full equations. We've never added equations all together. So take this one with as much time as you need, and you will, after this, have 3 methods to use, and you just kind of choose the one that works best for you. So, step 1 says, line up the equations so that the x's and the y's are in line. And you can see that I've color-coded both equations from the top, and really they are already in line. I've got x's first, then y's, then my equal sign, and then my constants. So these are in the correct order. When we get to the practice problems, I'll show you what to do if they're not already in the correct order, but you know how to rearrange by this point. So whenever we rearrange, we have rearranged into y equals mx plus b. We can rearrange into whatever we want as long as we follow our math rules. So step 1 is done. We've got the correct order. In step 2, we need to look and see if either our x's or our y's are already opposites. In this case, our y's are. They have the same digit of 5. One is positive and one is negative. That means that when I add them together, they will make a 0 pair and go away. And that's exactly what we want. We want them to eliminate. So if you're already lucky enough that your equation is set up like this, you skip and go right on to step 3. If they do not, like if it was positive 5y and negative 1y, you just have an extra step which says to multiply both of the equations by a number, and specifically by the least common multiple. Least common multiple. That is from 6th grade, which means the smallest number that they both can multiply into, because we want to make them the same digit and we want to make sure that they're opposites. So sometimes you might need to multiply one equation by 2, or one equation by negative 2. And sometimes in really hard equations, you have to multiply both equations by something different. But we'll see that in the practice. In this case, we've already got it ready. We've got our opposites. We are ready to go to step 3 and to add our equations together. So you can see that my x's are in line. I'm adding them all up. 2x's and 6x's together makes 8x's. My y's have been eliminated, and my constants add up to 8. So my equation is now 8x equals 8. Now I'm going to just continue doing that work, and I'm going to solve for x. So I will divide out the 8 to find that x equals 1. From here on out, it's the same work we've been doing. I've figured out x. Now I need to plug x back into one of my equations. So I was using this one, the top one, because as I said, I always use the top one. Plug that in. Now I'm able to solve for y. Go through my whole process, and I find that y is 3. Ready to write my ordered pair. Here's my x answer. Here's my y answer. Write it in parentheses, and then I'm going to take both of my equations one at a time. First this one, plug in my x value and my y value, simplify. I do get a true statement, Now let's make sure the next one is correct. So here's my second equation, plugged in with x and y. True statement, done and done. All right, there are 4 try-it problems, just like we've seen. 1 and 2 are similar to what you saw in the notes, where the terms are already in the proper order, they're all lined up, and you already have your opposites. So we've got 2x and negative 2x to go away, and in this case it's actually, it's our y's that are going to go away. So in this case we'll solve first for x, okay? In this case we'll solve first for y. But I want to look at number 3 and 4. Number 3, they're still lined up, but I don't have anything that is already an opposite. I chose the x's. It doesn't actually matter. You could have worked with y's either. So let's look at number 3. I had a negative 1x and a positive 2x. Well, I like that I've already got a negative and a positive, but they're not the same number. So what I did is I took this whole equation, multiplied it by 2. That's our distributive property. 2 times negative 1x is negative 2x. 2 times negative 2y is negative 4y. 2 times negative 20 is negative 40. Now, for this moment, I'm going to pretend that this equation is gone. I'm going to use this set of equations. So I've just manipulated that top one into a different form, because now I do indeed have my pair of opposites that are going to eliminate themselves. Number 4 is extra tricky because I don't have anything that I can multiply one equation by to make it an opposite of something in the other. So again, I could have chosen x's just as easily here. I chose the y's. I saw that 2 and 3, they both have a least common multiple of 6, because 2 times 3 equals 6, and 3 times 2 equals 6. I did like that I already have a positive and a negative, so I just had to take this equation that has started with 2 and multiply everything, scale it up by times 3. In the second equation, I had the 3, so I'm going to times everything by 2. So my top equation becomes this one when it's 3 times bigger. My bottom equation becomes this one, and now my x's are going to eliminate. So give that a try. Do check your answers in the link on Canvas, and let me know which problems, if any, are giving you a hard time. All right, y'all, thanks for sticking with it. See ya.